Okay, we are in part 2 of this video because I had to stop recording because you lovely people came in and we had to do all the things. So we are continuing. I'm on number 6. So we have 1 and 2/9 divided by 5/6. So we need to convert our mixed number to an improper fraction. So just draw my little arrow down here. We have our denominator times our whole number, which is 9, plus 2 more is 11. And then remember our denominator stays the same, 11 over 9. Whoops, no. And I was divided by 5/6, okay? So remember, we're going to rewrite our mixed number to an improper fraction and maintain the rest of our expression here. And then we're going to do our keep change flips. I'm drawing my arrow right here. So we're going to keep our first fraction, 11 over 9, changing our division to multiplication, and then we're going to flip our fraction 5/6 to 6/5, which is also the reciprocal, okay? Now we can cross simplify. Now I know some people get a little overexcited about this. Remember, examine your digits first, okay? So if I'm looking at 11 and 5, if I'm looking at my factor chart that I gave you, I know that 11 is prime and 5 is prime, so the greatest common factor is 1, so you don't need to simplify. You can't. But 9 and 6, the greatest common factor is 3. So if I divide both of these by 3, I get this. 11 over 9 divided by 3 is 3 times 6 divided by 3 is 2, and then 5/5. Okay, so now I can multiply across, because in this particular example, every single one of these digits is prime. So now I get 11 times 2 is 22, over 3 times 5 is 15. Now in this case, my numerator is greater than my denominator, so I have to divide. So 22 divided by 15. 15 goes into 22 one time. Subtract, and I get 7. And then when I rewrite my mixed number, 1, my quotient here is my whole number. And if you're stuck, remember your denominator stays the same. 15. My remainder is 7. Okay, so that's what we got right there. Now, another good thing about cross simplifying here is that when you simplify this to where the greatest common factor is 1, even though we have an improper here, when you get over here and divide, you end up with a fraction that is already simplified, meaning the greatest common factor of 7 and 15 is 1, so you can't simplify anymore. So please remember that. Number 7, I have 3 divided by 2 and 2/5. So I have a whole number right here, and I have a mixed number. Now we need to convert both of these to a fraction. So I'm going to draw my arrow. So remember, a whole number as a fraction is 3 over 1. Okay? So 3 over 1, because 3, there we go. Because 3 divided by 1 is 3, okay? Then divide. And then my mixed number, denominator times whole number, 5 times 2 is 10, plus my numerator, 2 more, is 12. Over 5. So now I have my division, but now I need to convert this to a multiplication problem, okay? I'm going to go down here. So we're going to keep the first fraction, 3 over 1, change division to multiplication, and we're going to find the reciprocal, which is the same thing as flipping my fraction, where 5 becomes my numerator, 12 becomes my denominator, okay? And then if I'm going to cross simplify 5 and 1, well, 1 is not a prime, nor is it composite. It's just 1 all by itself. But 5 is a prime number because it only has 2 factors, 1 in itself. So I cannot cross simplify them. But 3 and 12, the greatest common factor is actually 3. So 3 divided by 3 is 1. over 1 times 5 over 12 divided by 3 is 4. So now I have, when I multiply, I get equals 5/4. So over here, I have to divide because 5 is greater than 4, so it's improper. 4 goes into 5 one time. 5 minus 4 is 1. And then I get my whole number, it's my quotient. When I build my fraction, my denominator stays the same. And then my remainder is 1. And again, when we cross simplify, we end up with a fraction that is already simplified. So again, our mixed numbers need to become improper fractions. So 3 times 5 is 15 plus 1 is 16. Our denominator stays the same, 3, divided by, denominator times whole number is 9, plus 1 more is 10 over 9 because my denominator stays the same. Then I'm going to keep my first fraction, change my division to multiplication, and then flip my second fraction. And now I can cross simplify. So I'm going to look at 9 and 3 first because I know that 3 is a factor of 9. So, and 3 is a factor of itself. So 3 divided by 3 is 1. 9 divided by 3 is 3. The greatest common factor of 16 and 10 is 2. So 16 divided by 2 is 8. 10 divided by 2 is 5. Okay, so when I rewrite that down here, just so we don't have a mess, 8 over 1 times 3 over 5. And I get 24 over 5. Now it's improper, so I do need to divide. So 24 divided by 5. 5 goes into 24 4 times. Whoops, 5 times 4 is 20. I get 4. So my whole number is 4. My denominator stays the same, which is 5, and my remainder is 4. And because I cross simplify back over here, I don't have to simplify my final fraction in my mixed number. Okay. Okay. So what you're going to need to do on your own. Okay. Do not worry about number 12. Whoop. Come down here. Okay. But you're going to need to do 9, 10, and 11 on your own. So if you're not with us or we're in class, this is independent. You can flip back to the front and use your notes, as I encourage you to do. You can also use your factor paper that I made you and the multiplication chart, all the things, okay? And then you also have some word problems. Let's talk about these word problems, but you are going to solve them. A container of juice contains 10 7/8 cups. If the serving size listed on the package is 3/4 cup, how many servings are there? So we have to ask ourselves, what are we dividing? Okay, am I dividing my container of juice or one serving of my juice? Yeah, I'm dividing my juice. So I would divide 10 7/8 divided by 3/4 so I can figure out how many servings there are in each container. Number 14, how many bracelets can be made using 10 5/6 feet of string if each bracelet requires 5/8 feet of string? So again, I have 10, that's a lot, 10 5/6 feet of string. And I'm going to break up that string into 5/8 feet of string, okay? So less than a foot. I'm going to be breaking this up. So we are dividing this big string, and we're going by 5/8 are the pieces we need, and we have to figure out, well, how many bracelets can I make, okay? One thing I want you to think about, I don't know at this moment if this is going to be a whole number or a fraction, but I want you to think about, if it ends up being a mixed number, think about it. Can you use part of a string that's not complete? So think about that when you are writing your statement at the end. Number 15, Mr. Kessler is filling test tubes with a solution used with his science students. If he has 220 milliliters of solution and each test tube can hold a maximum of 9 1/3 milliliters, how many test tubes will he need? Okay, that's another one to think about. Even if you have a little bit of leftover, it's got to go somewhere. So you got to think about when you have your quotient, how many test tubes do I need? Okay, so you got to work that out and be aware that 220 is a whole number, and whole numbers must also be converted to fractions before we can divide and multiply. Okay? All right.